Hi, this is our group data Summative by Ramin, Jasdeep, and Kieth.
Research topics and variables. Our variables are average retirement age and life expectancy, with life expectancy being our independent variable and the variable split into two strata of male and female.
The premise for our research is to analyze the relationship between the two variables because understanding how much longer or shorter one has to work in relation to one's life expectancy is important, or if there even is a relationship. It would be important information that people would want to know. So for our histograms for life expectancy, in all three, the mean, median, and mode are very similar to each other, which is a characteristic of a normal distribution. Although once we did the standard deviations of each three histograms, all three did not have a normal standard deviation in the first standard deviation. Our histograms are not skewed because our mean, median, and mode are very close to each other, but they don't follow a normal distribution either, which would mean our histograms are not left, right, or normal.
The life expectancy for males is most occurring in the years between 73 to 75 years of age.
The life expectancy for female is most occurring during the age 80 to 82 years of age, which is higher than the males. The female overall have a higher life expectancy than the males.
The most occurring life expectancy for male and females is from ages 77 to 78 years of age.
So for our standard deviation for average life expectancy, the males had a higher standard deviation with 1.7 compared to the females with 1.02. This shows that the average spread of data for males is higher compared to the women, which shows that the males are less consistent than the female life expectancy.
Our box and whiskers plot represents how the males have a lower life expectancy and a higher spread of life expectancy compared to the females. The males' max values for the highest life expectancy is between the females' min and Q1 values. This shows that on average females have a higher life expectancy. The spread of our data is also very even from our min, Q1, median, Q3, and max values for all three plots. Do not have a large spread of data, showing the accuracy of our plots and no outliers.
The histogram of our dependent variables represent a right-skew distribution. Firstly, by visually looking up at our histogram, it looks like it's a right skew. It also shows the average retirement age is the most occurring during the age 61 to 63.
Our average retirement box and whiskers plot shows that from the min value, Q1, median, and Q3 and max points, the spread of data is very even. Although there's a higher spread of data from Q3 to our max value, the spread of our data from min to max is very low, which is 3.8 years. This shows that overall retirement age is quite consistent and our data is very accurate with no outliers.
Our data shows that overall, as a life expectancy increases, the average retirement age decreases. Although the most recent trend in data shows that as life expectancy increases, the average retirement age also increases. Although the majority of data shows that as the average retirement age decreases, life expectancy increases.
Our life expectancy correlations for three categories of life expectancy shows a visually perfect positive correlations. This is likely because life expectancy had only increased since 1981. Our retirement age correlations is moderate to strong negative correlations. This is likely because the trend in the data has recently changed, which caused a change in the correlation coefficient.
So for the validity of our data, firstly, stats can acquire their death database information with no sampling. It was done with a census, and this means that the data used was a very accurate representation of the population, as it represents the population as a whole. Secondly, StatsCan has done extensive work to minimize the margin of error in their work. Once data is received and confirmed it's correct, it goes through process of being analyzed and gets looked for things such as outliers. Overall, when such a large amount of data is being analyzed, there will be room for error, and StatsCan has managed to keep that margin of error at less than 3%, which makes it a very accurate representation of the data. And finally, although the data for the death database is quite accurate, the labor force survey is not as accurate. The labor force survey used sampling surveys, which makes it vulnerable to sampling and non-sampling errors, and these errors include coverage errors, non-response errors, response errors, and interviewer errors, coding errors, and other types of errors that occur during the processing. and the non-response is also around 10%. And although StatsCan attempts to connect to non-responders, there still remains a percentage of households that do not respond and creates non-response bias.
Insurance companies and pension planning companies would find this data valuable because they would adjust how they charge and create plans depending on how much longer or shorter people are going to work in relation to life expectancy. Human resources of any company would also find this data useful because of the hiring process. Age will certainly play a big factor. If life expectancy increases or decreases, retirement age is affected. Companies would adjust their age for hiring appropriately.
So in general, women are most likely to live longer than men and have more constant life expectancy. Our data is quite accurate and doesn't have outliers, as displayed through our box and Whisker plots.
So to conclude, the data indicates that as life expectancy increases, average retirement age decreases. But if recent data shows that as life expectancy increases, retirement age also increases. So although we cannot give a definite answer to if retirement age increases or decreases in relation to life expectancy, we know that more of the data shows that as life expectancy increases, the retirement age decreases.
Thanks for listening.